Welcome to my YouTube channel. So here today we are going to be solving the binomial theorem. We are going to expand using the binomial theorem. What are some of the things that we need to know? We need to know some rules on the factorial theorem. So how does it work? So like for example, the factorial theorem states that if you have 3 factorial, it means to say you're multiplying the same number 3 going until you reach 1. So it will be 3 times 2 times 1, which will be equal to 6. If you have 5 factorial, which should be equal to 120 if I'm not mistaken, we are going to have 5 times 4 times 3 times 2 times 1, like that. Then this is going to give us 5 times 4, that's 20, 20 times 3 times 2. So we are going to have 3 times this, we are going to have 60, 20 times 3 is 60 times 2, which will give us 120. We can continue like that to 6 factorial. So 6 factorial is equal to 720, which will be 6 times 5 times 4 times 3 times 2 times 1. So we have this whole thing. If you multiply, we have already found that it's 120. 120 times 60, it will be 0. This times this, it will be 2 remainder 1. This times this, we are going to have 6 plus 1, that will be 720. So now, under the binomial expansion, we are going to be using the combination. What does it mean? You might have something like 12 combination 3, which can sometimes be written as 12 and a 3, like this. So this is the combination. So we are going to have, so this means that whatever number is on top, we are going to have your 12 factorial like that, over, you are going to have, then let me write it in terms of the numbers. It will be n factorial, where we have, if we have n combination r like this, where r is the number down, n is the number up there. So we have n factorial over, we have our n, the same n, you subtract the r, then you're going to say factorial like that. Then you repeat this same, which is your r factorial. So that means to say, if you are required to evaluate the value of this, your 12 combination 3, which is equal to your 12 combination 3, this can be written as, where there is n, we are going to put the number there, which is 12 over, so 12 factorial over, we have our 12 minus the r, which is our 3 factorial, then we have our 3 factorial, like that. Now remember one thing is that if you have your factorial, it means to say you are going to have let's say if you have your 5 factorial, 5 factorial is the same as 5 times 4 times 3. You can even write it as 3 factorial, because you know already that 3 factorial will stand in for 3 times 2 times 1. So you can, it's okay if you write 5 factorial is equal to 5 factorial times 4, or 5 times 4 times 3 factorial, which would still be okay if you write 5 factorial to be 5 times 4 factorial. 4 factorial would represent 4 times 3 times 2, which won't change the meaning. So this means that since you do not have the calculator, this is what you are going to be doing. So we are going to have the 12 factorial. So before you write what 12 factorial is, look at your denominator, over 12 minus 3, that's 9. So you are going to have over 9 factorial, like that. Then we have times our 3 factorial, like that. So with this, we are now going to look at the highest factorial down here is 9. So you are going to expand your 12 until 9. So it will be your 12 times 11 times 10 times 9 factorial, like that, so that they can cancel each other. So you have 9 factorial, 3 factorial, this and this goes. So you are going to have your 12 times 11 times 10. And you know to say your 3 factorial is 3 times 2 times 1. So evaluating this, we are going to have our value of, we have our 12 times 11 times 10, then over 3 times 2, that's 6, times 1, that's 6. we divide 12 divided by 6, that's a 2. So we are going to have 2 times 11, it will be 22 times our 10. So which is going to give us 22 times 10, we are going to have 220 like that. So this is the 12 combination 3, which was the same as written like this. So this is very, very important, as we are going to be using this knowledge. So that will give us 220. If you have 9 combination 2, which is the same as written like this, we are going to have 9 factorial over, you subtract 9 minus 2, then you write the factorial over the 2 factorial like that. So this is going to give us a value that is equivalent to, we have 9 factorial over, we have 9 minus 2, that will give us 7 factorial, 2 factorial like that. Then 9, since 7 is here, we are going to multiply until we reach 7. So we have 9 times 8 times 7 factorial over, we have 7 factorial times our 2 factorial, which you can just write as 7 factorial 2 factorial. This and this cancels. We are going to have 9 times 8 over 2 factorial is 2. So we are going to cancel, not there but here. We have 4. So our 9 times 4 will give us a value that is equivalent to 36. So that is the value for our 9 combination 2, which is the same as our 9 2 like that. Last but not the least, if we have 8 combination 6 like this, we are going to have a value that is equivalent to 8 factorial over our 8 minus the 6 factorial, then repeat the 6 factorial, which will give us a value of 8 factorial over, we have 6 minus 8 minus 6 is 2 factorial, then we have 6 factorial. Since 6 factorial is the highest, we are going to reduce until 6, which will give us 8 times 7 times 6 factorial over, we have our 2 factorial times our 6 factorial. This and this cancels. We are going to have 8 times our 7 over our 2. You cancel, you are going to remain with 8. 4 times 7, this will give us a 28. So this is the value of 8 combination 6, which is equal to 8 6, which is just the same. It can be written like that, it can be written like that. Now if we are required to expand something that is like this, let's say we have a plus our b to the power of n. So this one shall be equal to, you're going to be using your combination, so you can write your n, then the first one, it will be 0 like that. You are multiplying it with this one. So you're going to say your a will be, you have your a b like that, you are going to write your a b like that, then you have plus your n combination 1, then you have plus then you're going to have your a b again, then you have plus your n combination 2, then you're going to have your a and b like that. Now the thing is that the way it is, you're going to be reducing, so the power, the first one will have power n, then here it will be your n minus 1, then you have your b like that, then here it will be n minus 2, then here it will be power 0, power 1, power 2 like that, power 2 like that. And we can continue plus until we reach where n becomes equal to the r. So remember, this n combination 0 is the same as n combination r. Now r, your first r will be 0 until you reach n combination n. Then you are going to multiply your a to the power of, now this n, a is reducing. So when a reduces, when n, you have your n minus your n. That's the thing. So when you have your n minus your n, then you have your b to the power. So b is 0, 1, 2, 3, 4, 5 until b reaches the value of n. So this is the binomial expansion. Now n minus n is 0, a to the power 0 is 1. So you are going to find that you are going to have n combination 0. Then you have b to the power 0 is a, is just 1. So you have, this is your, like your final thing. You have n combination 1. Then you have your a, n minus 1. Then you have your b, like that, it's power 1, which can just be b, plus your n combination 2. Then you have your a, n minus 2, b to the power of 2, like that. Then you have plus, you have your n combination n. Now one thing that you need to know is n combination 0 and n combination 1, or n combination 0 and n combination n is equal to 1, like that. So 1 times a to the power of a, n minus a to the power 0, n minus n is 0. Then you have your b to the power of n, which this case it is just 1, like that. Now with letters it might be a bit difficult for you to understand, but let's now involve numbers. So if you are required to expand using the binomial expansion, let's say we have our 2x minus our y, like that. Let's say we have to the power of 4. So how do you expand this one? So if we have 4 terms, it means if we have power 4, it means we should have 5 terms. So we are going to have our, you're going to just write your 2x times your negative y, like that. You're going to write these values until there are the 5 of them. So you have your 2x, then you have your negative y, like that. You have your 2x times your negative y, like that. You have your 2x times your negative y. As you can see, I'm leaving some space. You should leave these spaces. So you have your 2x negative y, like that. Then the power, it will be reducing. So the normal thing as the Pascal's triangle. So you're going to have your power is 4, your power is 3. Let's change the color. So from 3 we are going to have our 2, we are going to have our 1 and 0. So just be careful, put these in brackets, put these in brackets, 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 brackets. Then we are going to have your 0, 1, 2, 3, 4, like that. So that is how you are going to be doing that. Then all you have to do is, we are going to put the combinations, your 4 combination 0. So the 4 combination 0, 4 combination 1. Now due to space, I'm going to create something that is separate. 4 combination 1. Now I don't have space, so I'm going to write this after I expand a bit. So this will give me a value of 2 to the power 4. It will be equal to a 16 x to the power of 4, like that. Then the next value that we are going to have is because negative y to the power 0 is 1, so we have a 1 there. Then we have plus 2 to the power 3 is 8. Then we have our x to the power 3. Then we have times negative y, like that. Then 2 to the power 2, that's 4. X to the power 2, that's x squared. Then we have negative y squared, it will give us y squared, like that, positive for that matter. Then we are going to have plus 2x to the power 1, that will just be 2x, times negative y to the power 3, it will be negative y to the power 3. Then we have 2x to the power 0, that's 1. Then our negative y to the power 4, that will be our y to the power of 4, like that. So this is going to give us our 16x to the power 4. Then we have plus our 8x negative for that matter. So we are going to have negative 8x cubed y, like that. Then we have plus our 4x squared y squared. Then we have negative minus, this times this is negative 2x y to the power 3. Then we have plus our y to the power of 4. Now putting the combinations. So the combinations, I did this because of space. So putting the combinations, we are going to have a value that is equivalent to, we are going to say our 4 combination 0 times we have our 16. This will prevent you from making mistakes. 16x squared, x to the power 4. Then we have minus here. So we write our minus 4 combination 1. Then we have times our 8x cubed. Is it cubed? Y like that. Then we have plus our 4 combination 2 times our next value is 4x squared y squared, 4x squared y squared like that. Then we have plus our next value, it is minus, so we are going to say minus, so 4 combination 3. Then we have our 2x y cubed. Then we have plus our 4 combination 4. Then we have our y to the power of 4. So remember, any number combination 0 is the same as itself, combination itself, which should be equal to 1, like that. So wherever you see this, just know that it's 1. So we are going to have our 1 times our 16x to the power of 4 minus, we are going to have 4 combination 1, it will be equal to, so any number combination 1, it is itself. So there the result will be equal to itself. So those are some of the things you need to know. But you can always prove that when you have 4 combination 1, we are going to do the same. We are going to have 4 factorial. Then we have over our 4 minus 1 factorial, 1 factorial, which will be equal to 4 factorial over 4 minus 1, that's 3 factorial, times 1 factorial. So if we are to reduce this, it will be 4 times 3 factorial over, we have 3 factorial times 1 factorial. This and this will cancel, and 1 factorial is 1, so we are going to remain with 1. So just any number combination 1 is itself. So we are going to have 4, then we have times, we have our 8x to the power 3 y like that. Then we have plus, so here we have to labor, we are going to say 4 factorial over, we have our 4 minus 2 factorial, 2 factorial. Then we are multiplying it with times our 4x squared y squared like that. So we have how many terms? 1, 2, 3 terms. The power is 4. Then we are here, we are going to do the same, which will be also any number combination, a lesser number by 1 is itself. So those are some of the things that will increase your progress. So we are going to have minus, we are going to say 4 factorial over our 4 minus, without wasting time. So 4 combination, a number less than it is just that number. So we are going to have minus 4. You can prove it by saying 4 combination 3. It will be 4 factorial over 4 minus 3 factorial, 3 factorial, which will give us 4 factorial over 4 minus 3 is 1 factorial, 3 factorial like that. So we have our 4 times our 3 factorial over our 1 factorial times our 3 factorial. This and this cancels. We are going to remain with 4. So it is itself. Then times our 2x y to the power of 3 like that. So then plus 4 combination itself is 1. Then we have times our y to the power of 4 like that. Then last but not the least, we are going to get a value that is equivalent to, we have our 16x to the power of 4. Then we have minus 4 times 8. This will give us a value that is equivalent to 32x to the power 3 y like that. Then here we have plus 4 factorial over 4 minus 2 is 2 factorial times 2 factorial like that. then we are going to have times 4x squared y squared. Then we have minus 4 by 2, that will be 8xy cubed. Then we have plus our y to the power of 4. So we are just remaining with this value. So don't do it like this. So that's the beginning of witchcraft. If you say 2 factorial times 2 factorial is equal to 2 times 2 is 4, then you say 4 like that. No. And you do a factorial do this. No, that's not the way it works. So let's just evaluate the value there. So we are going to have 4 factorial is the same as having, let's just evaluate the value there so that we do not write a lot. So we have 4 factorial over 2 factorial by 2 factorial. Then we have times our 4x to the power of 2, y to the power 2. So we are going to have a value that is equivalent to 4 factorial is the same as 4 times 3 times you end on 2 factorial, since that's the value there. Then you're going to say 2 factorial times 2 factorial like that. Then we have times 4x squared y squared. So this and this will cancel. So we are going to remain with 4 times 3, which is going to give us a 12. So we have 4 times 3, which is going to give us a 12. 12 over 2 factorial will be equal to 2 times 1, which will be equal to 2. So we have 2 times, we are going to have a value that is equivalent to, we have 4x squared y squared. This and this cancels. We are going to remain with 6. 6 times 4, it will give us a 24. So we have 24x squared y squared. So that's the value there. So we are going to write our 16x to the power 4 minus our 32x to the power 3y. Then we have plus, so we have evaluated this, we have found it to be equal to 24x squared y squared. Then we have minus our 8x y to the power 3 plus our y to the power of 4. So that is our value there. So that is the value there. So that is how we solve that one. Let's look at our next example. So we have our b, which is equal to x minus 1 over x to the power of 8. So this one will be very, very interesting. This will be very, very interesting. So just need to be careful. So we have, if we have power 8, it means to say we should have 9 terms. So how are we going to do this? We are going to say our x like that. Let's begin by expanding, then put the combinations. So we have our x by negative 1 over x. We have our x by negative 1 over x until we get all of them. So let me just write fast until we get 9 of them. X, then we have plus our x, negative 1 over x like that. So from there we are going to, we have 9 terms, 1 2 3 4 5 6 7 8 terms. So we are supposed to have 9. So we have this value. So we are first expanding. So the power is 8. So we are going to begin with 8 and so we have 8 7 6 5 4 our 3 2 1 0. Then begin 0 1 2 3 4 5 6 7 8 like that. So those are our values. We have 9 of them. So our final answer will be, not our final answer, but without the combinations, x to the power of 8, because this is 0. Then we have plus our x to the power of 7 times our negative 1 over x, 1 to the power, this is just itself. Then we have plus our x to the power 6. Negative 1 squared is positive 1 over our x squared is x squared, like that. Positive for that matter. We have plus. We have our x to the power 5. Then we have times negative 1. Negative 1 to the power 3 is negative 1 over. We have our x to the power of 3, like that. So we have 1, 2, 3, 4. Then next one will be x to the power of our 4 times 1 over this negative 1 to the power 4 is positive 1 over our x to the power of 4, like that. We continue. We are going to have plus our x, as you can see it's power 3, so we have our x to the power 3. We are here. Then negative 1 to the power 5, it's negative 1. So we are going to write times negative 1 over. We have our x to the power 5. The next one, we say plus x to the power 2. So we write x to the power 2 times. We have 1 over. So we are going to have positive since this power is even. So we have x to the power of 6, like that. Then we have our plus our x to the power of 1. Then we have our negative 1 to the power negative 7. 7 is odd, so we are going to have negative 1 over. We have our x to the power of 7, like that. Then last but not the least, we are going to have x to the power 0 is 1. 8 to the power negative 1 is positive 1, so we are going to write 1 over. We have forgotten about this because x to the power 0 is 1 over. We have our x to the power of 8, like that. So to evaluate this, we are going to have our x to the power 8 as our first one. We cancel this. We are going to remain with 6. So we are going to say plus, or rather minus, negative 1 times this. It will be negative x to the power 6. Then we have this and this. We are going to have 4. So we are going to have 6 minus 2 is 4. So we are going to write our plus x to the power of 4, like that. We are here. This and this. 5 minus 3. You can just cancel, but you are just subtracting. 5 minus 3 is 2. So we are going to say plus x to the power of 2. We are here. 4 divided by 4, that's 1. So we are going to write our 1 like that. Then we have, for the next one, 3 minus 2. That's negative 2. So that means to say down here, that's where you are going to remain with a value. So we are going to say minus, since we have a negative. So we have minus 1 over our x to the power 2. If it was greater, it could have been up there. Then we have plus, same here, 2 minus 6 is negative 4. So we have 1 over x to the power 4. You can agree with me that 2 minus 4, it's okay if you write 4 to the power negative, x to the power negative 4, which is still correct. Then we have this one, where we are going to have, why are there a few? Let's see first. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's okay. So this and this, we are going to have a minus 1, negative times positive negative. Then we have over, if you divide that, we are going to get x to the power of 6. If you divide this, then last but not the least, we are going to have our 1 over x to the power 8. So we have positive 1 over x to the power of 8, like that. So that is without the combinations. Now after doing this, we can put the combination. If you want, you can put the combination. Now for me, my screen wouldn't allow me because of space. So after that, you are going to put all the combination. It's 8. Now you are going to put all the combinations. So we begin 8 combination 0, 8 combination 0, x to the power 8. Then we have minus 8 combination 1. Then we have our x to the power 6. Look at the sign, plus. We have 8 combination 2. Then we have our x to the power of, it's reducing by 2. So we have 4. Then we have plus, is it plus? We have plus 8 combination 3. 8 combination 3 for the next one, times our x to the power of 2. Then we have plus our 8 combination 4 like that, times we have our 1 like that. Then the next one is a minus 1 over x squared. So we are going to say minus our 8 combination 5 times our value, which is our 1 over x squared. So we have 1 over x squared. Then we have plus 8 combination 6 times, we are going to have our 1 over x to the power 4 plus, is it plus or minus? It's minus, minus 8 combination 7 times our 1 over our x to the power of 6. Then we have plus 8 combination 8 times our 1 over x to the power 8, like that. So we know that 8 combination 0 is 1, so the answer there is just x to the power 8 minus 8 combination 1. Any number combination 1 is itself, so we have minus 8 times x, it will be 8x to the power 6. Now here we need to do some math, so we are going to have our 8 factorial over our 8 minus 2 factorial. Then we have minus our 2 factorial, 2 factorial like that. Then we have times x to the power of 4 like that. So we are going to continue this until these two terms, 8 combination, a number less than it by 1 is just itself. So now we are here, so we are going to do the same. 8 factorial over, we are going to have our 8 minus 3 factorial, 3 factorial like that. Then we have our x squared. Then we have plus our 8 factorial over our 8 minus 4 factorial. Then we have 4 factorial like that. We are multiplying this by our next value, which is it's 1. So we multiply by 1 like that. The next one, we are going to have minus 8 factorial over our 8 minus 5 factorial, 5 factorial like that, times 1 over x squared. Then we have plus our 8 factorial over our 8 minus, so yeah, it's a lot of work, 8 minus 6 factorial, 6 factorial, times, what do we have? We have 1 over x to the power 4. Then the next one is 8 combination 7, it's 8 itself. So any number combination, a number less than it by 1 is itself. So we are going to say minus our 8 times 1 over x to the power 6. Then 8 combination itself, that's 1. So we are going to have plus 1 times 1 over our x to the power of 8. So to evaluate this, we are going to have our x to the power 8 minus our 8x to the power 6. Then we are here, so we have plus our, now to, okay, so we have our 8 times, we are going to say 8 times our 7 times 6 factorial. Remember, 8 minus 2 is 6 factorial. Then we have 2 factorial like that, times our x squared, x to the power 4, sorry, like that. So we have ended on 6 because 6 is the highest number here. So we are going to do the same for this. So we have plus our highest here, 8 minus 3, that's 5. So we have 5 factorial times our 3 factorial, which is going to give us on top 8 times 7 times 6 times 5 factorial like that. Then we have our x to the power of 2 like that. Then from there we are going to say plus. We are going to say plus our 8 factorial over, we have 8 minus 4 is 4 factorial times our 4 factorial like that. So we have written 8 minus 4 is 4 factorial. Then we have times our 1 like that. Then we have, where are we? So we have there, we have plus our 8 factorial over, we have 8 minus 5, that's 3 factorial, 5 factorial times 1 over x squared plus we have 8 factorial over 8 minus 6, that's 2 factorial times our 6 factorial, which will give us times our 1 over x to the power 4 like that. Then we have minus, okay, let's just use down here. So this question was cumbersome. We have our negative 8 over 8 times 1 over x is over x to the power of 6. Then last but not the least, we have 1 over x. So we have plus 1 over x to the power of 8. Yeah, so let me just reduce this a bit. So let us simplify. So this 6 and this 6 are common. We reduce. This 5 and this 5 are common. We reduce. This, why didn't I do this? Let's just move this a bit. So, okay. So to change our 8 factorial, we are going to go down until 5. So we have times 7 times 6 times 5 factorial, so that this and this can cancel. So same here, we are going to reduce it until, what's this? We reach 6. So we have 8 factorial is equal to, we have times 7 times 6 factorial like that. So we cancel this, we cancel that. So this is what we have. We have cancelled. So let's just now write things. We have our x to the power of 8. We have minus our 8x to the power 6. We are here. We write our plus. Is it plus or minus? Plus our 8 times 7. Then over our 2 factorial is 2. Then we have our x to the power 4. Then we have our 8 times 7 times 6. So we have plus 8 times 7 times 6 over our 3 factorial is equal to 6. So if you do 3 times 2 times 1, that will be 6. 6. Then we have our x squared like that. Okay, so let's just evaluate this value without doing the calculation there. So we have 8 factorial over our 8 minus, we have our 4 factorial, 4 factorial. So this is going to be 8 times 7 times 6 times 5 times 4 factorial over our 4 factorial times our 4 factorial this and this cancels. We are going to have 8 times 7 times 6 times 5 over 4 factorial is the same as 4 times 3 times 2 times 1, like that. So this and this cancels. We are going to remain with a 2 here. This and this cancels. We are going to remain with a 2 here. This 2 and this 2 can cancel, so that we just remain with 7 times 2 times 5. So 7 times 5, that's 35, times 2, that is equal to 70. So we are going to write 70. So this is 70. So we are going to say plus 70, like that. 70 times 1 is 70. Then we have our 8 when we do our calculation. So we are here 8 times 7 times 6 over 3 factorial. So we have our 8 times 7 times 6 over 3 factorial is 6. Then we have times 1 over x squared, like that. Then we are here 2 times 7. So we have 2 times 7. 2 times, is it 2? 8 times 7. So we have 8 times 7 over 2 factorial is 2. Then we have times our 1 over x to the power of 4, like that. Then we have minus 8 over x to the power 6 plus 1 over x to the power 8, like that. So the final value that we are going to have is our x to the power 8 minus 8x to the power 6 plus this and this cancels. We are going to remain with a 4. 4 times 7, it's 28. X to the power 4. This and this cancels. 8 times 7, that will be 56. So we have 56. Is it supposed to be positive or negative? Let's see. Yeah, you can. So it is this one that was given us. Is it this one? Okay, looks okay, but you can just verify just in case there's a mistake. So we have 56x squared. Then we are here plus 70. Then we have here, this is where the mistake is. Here it's supposed to be a negative. If you look at after the one that is producing the 70, where is it? If you look, this one, it's this one that is producing the 70, the one that is being multiplied by 1. But here we have a negative, so we have to apply that negative. We have minus this and this, so we have minus 56 over our x squared. Then we have our 8 times 7. We are here. This and this cancels. 4 times 7, that will give us 28. So we are going to have positive 28 over x to the power 4. Then the next one is minus 8x to the power 6, like this. Then finally 1 over x to the power 8. Yeah, this was cumbersome, but that is how basically you need to go about it. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.